loud. So let me just.
This is being recorded.
All right. So I'm curious. I have the third edition of the Structure of Scientific Revolutions, and let me call on you in order on my screen. Lisa, what edition are you reading from?
I haven't been able to get it yet. I haven't had a chance to get to the library to pick it up. So I'll be an active listener, but probably not a participant today.
Okay, well, you can feel free to stop us to ask questions, because remember, if you have a question, chances are one of the people who didn't get to participate has that same question. So feel free to stop us and ask questions. Linda, which edition do you have?
I have the 4th edition.
Okay, I've never seen the 4th edition. Is that one with an intro by Ian Hacking?
Yes.
Okay. So Barbary, which one do you have?
Mine is called the 50th Anniversary Edition, which also has an intro by Ian Hacking. So I don't know if
it's the same.
Okay.
It's the same.
All right. And Margaret, since you don't have your own screen, I figured I'd let everybody know who you were. And obviously you're reading along with Barbary today. You're muted. You guys are muted, I think.
She did that. You need to stop muting me. I did order an edition and it told me it was delivered, but I can't find it. So I'm bookless at the moment, but I think I ordered the 3rd because I got it used from something, but it's invisible. So I'll let you know when I actually get one, what edition I'll be reading from.
Okay. So anyway, in my edition, chapter 1 is the introduction, a role for history. How about your editions? Barbary, same thing? Okay, and Linda, same thing. All right. So I would like it if somebody else started reading aloud besides me, just so that I can pay attention to the waiting room and everything.
I'll start.
Okay.
Can everybody hear me okay?
We hear you. And if anybody has language that disagrees, just kind of speak up and say, yeah, mine is different, because we don't know whether the books are the same or different.
How far should I read?
Till somebody interrupts you or until you don't feel like reading anymore.
Okay, that's a way to do it. You guys can hear me okay?
Yes.
Okay, all right. A role for history. History, if viewed as a repository for more than anecdote or chronology, could produce a decisive transformation in the image of science by which we are now possessed. That image has previously been drawn even by scientists themselves, mainly from the study of finished scientific achievements, as these are recorded in the classics and more recently in the textbooks from which each new scientific generation learns to practice its trade. Inevitably, however, the aim of such books is persuasive and pedagogic. A concept of science drawn from them is no more likely to fit the enterprise that produced them than an image of a national culture drawn from a tourist brochure or a language text. This essay attempts to show that we have been misled by them in fundamental ways. Its aim is a sketch of the quite different concepts of science that can emerge from the historical record of the research activity itself. Even from history, however, that new concept will not be forthcoming if historical data continue to be sought and scrutinized, mainly to answer questions posed by the unhistorical stereotype drawn from science texts. These texts have, for example, often seemed to imply that the content of science is uniquely exemplified by the observations, laws, and theories described in their pages. Almost as regularly, the same books have been read as saying that scientific methods are simply the ones illustrated by the manipulative techniques used in gathering textbook data, together with the logical operations employed when relating those data to the textbook's theoretical generalizations. The result has been a concept of science with profound implications about its nature and development. If science is the constellation of facts, theories, and methods collected in current texts, then scientists are the men who, successfully or not, have striven to contribute one or the other element to that particular constellation. Scientific development becomes the piecemeal process by which these items have been added, singly and in combination, to the ever-growing stockpile that constitutes scientific technique and knowledge. And history of science becomes the discipline that chronicles both these successive increments and the obstacles that have inhabited their accumulation. Concerned with scientific development, the historian then appears to have two main tasks. On the one hand, he must determine by what man and at what point in time each contemporary scientific fact, law, and theory was discovered or invented. On the other, he must describe and explain the congeries. What is that word? Congeries, a disorderly collection or a jumble. That's a new word to me, of error, myth, and superstition that have inhibited the more rapid accumulation of the constituents of the modern science text. Much research has been directed to these ends, and some still is. I will pass the,
I was gonna suggest that we stop here, so that's good.
Okay.
So, first of all, I think this would be a good time for each one of us to share what, if any, scientific background we have. So can we go in the same order? Lisa, what's your relationship to science? Oh, you're frozen. You might need to turn your camera off for us to hear you.
I can hear now.
Okay, you're kind of breaking up.
I keep not.
Try turning your camera off. I think you're using more bandwidth than you have. Okay, so did you hear me ask for your background as it relates to science?
No, because the thing was roboting and I couldn't hear anything at all. It went mute and then it was roboting, so I couldn't hear anything that you had just asked. Sorry. Can you hear me now, though?
I hear you fine now. Were you able to hear the book being read?
Mostly, yes.
Okay, so anyway, my question is, what is your background as concerns science?
It's very basic. When I was in high school, obviously, you take high school science. It wasn't interesting to me. I was more interested in the arts. Science was just the class that I had to take. But now that I'm teaching, I find that it's interesting, but because I teach elementary school, what I do teach is elementary school level science. It's fun watching the kids kind of get those ahas and sharing with them. But again, I do not have a higher level of scientific background. It just was never my interest through high school and then into college either. So.
Well, as a high school teacher, I will be happy to share some of my ideas and observations about teaching science to little kids, because I think it's really important that we teach them not just scientific facts, but about what the scientific method is and how powerful it is. But anyway,
Definitely.
Linda, tell us about your relationship to science.
So yeah, I'm a scientist, I guess. I have a degree in veterinary medicine and equivalent to a master's in public health. And so I use science all the time for disease investigation and prevention. Biological sciences though, and this book is physical sciences. So there's a bit of a difference.
Right. Margaret?
The best public school secondary education that New York City could have offered. So no, I have no formal science training, just a healthy respect for it. And I feel like I learned quite a bit about the scientific method and its powerfulness. So I'm just here with an open mind, and I'm hoping to learn something.
Fantastic.
I'm a total layperson and a armchair intellectual, in quotes, with the emphasis on armchair. And I do work in a field that is extremely data driven, and model driven. And so the idea of, working on, how paradigms, how the vision of paradigms are formed, and how those things, may not be what we think they are, I think is actually really interesting, personally, but also potentially useful.
All right. And I will say that I've always been a science guy, but I managed to get a degree from Georgetown without taking a single science course. Oh, no, I did take cognitive science as an undergrad, but all the science courses that I really would have wanted to take happened at 7 or 8 a.m. and I was still playing music as part of my living. So I didn't take any courses before 10. But in the process of getting my degree in philosophy, I did take science of mind, and
Hello, doggies.
Science of mind. But the thing, I think what all of us will find as we continue reading is that science textbooks differ so much from what history of science reports that science is, that I have often said that science textbooks lie. And the difference between the way science actually works, as you'll see as we're reading this, is so profound. So did anybody have any questions or comments about what Barbary read?
I do have a question, Greg, on what you just said about the history of science versus what's in science textbooks. And I hadn't read, and Barbary's reading was so perfectly fluent and fast that I was sort of like, wait, there was something there, there was something there, there was something there. So I might have to go back and skim things. But what do you mean? What is the history of science? What does that mean? And is there more to it than just what the words imply?
Well, I'll at the risk of giving it away, right? Pretending this is a novel, I'd be giving it away. But
Okay.
For example, there's going to be a part that discusses the discovery of oxygen and how there are 3 or 4 men who could have a legitimate claim to having discovered it, but none of them actually wrote in their lab notebooks that they discovered oxygen. For example, one of them was doing his research under the phlogiston theory, and he wrote in his lab manual that he had produced dephlogisticated airs. And younger scientists saw that his results had actually proved the combustion theory, but the guy who's credited with the discovery of oxygen thought that people misinterpreted his results, and he died a believer in the phlogiston theory and kept trying to show that whatever the combustionists thought was wrong.
Okay, that helps. Thank you.
Yeah. Okay. So
yeah, my comments on that is that's not surprising to me. I think history textbooks are they're essentially lies. They're simplified to the point where there's not much truth left to them. And then my other thought on hearing this is that scientists don't rely on textbooks, right? Scientists rely on journal articles and things, because the textbooks are never detailed enough nor current enough.
One of the first things that we're going to learn is that the difference between a new science and a mature science is that, like, for example, there are books like the Optics and the Principia and so forth that were historically repositories of scientific knowledge. But once a science is matured enough so that it operates under what Kuhn called a paradigm, it's no longer necessary to talk about the science from its beginnings. And so basically scientists now trade in published papers that are so dense that laymen can't understand them. Right. And that's kind of the difference. Back 300 years ago, any learned person could read Newton or Galileo or so on and so forth, because the science hadn't developed to the point where it had its own jargon and was incomprehensible to anybody outside the field.
Oh. Yeah, no, that's a good point. And actually now we aren't even looking at published journals for the most part. We're looking at preprints.
Right. And of course that brings up different questions about legitimacy of research, because preprints aren't yet peer reviewed often.
And it's interesting. I was just made me think about peer review and how that is part of the, such an important part of the modern process. And I work at the World Bank in international development, and we try to use the trappings of things like peer review in our work, and then we act as if it is robust enough to create basically an evidence base, right? When in fact it's really quite weakened in terms of, just because you call something peer review and you get together some people to review it, doesn't mean that you have established fact. Right.
Well, fact is an interesting word as used in science. And by the way, I dropped an essay into the chat, and it's about archaeologists who work anonymously because the received wisdom in archaeology, there's a lot of people who think there's something wrong with it, but they can't get published because the peer reviewers are stuck on the old theory. And so they're meeting secretly and anonymously to challenge some of the received wisdom of archaeology.
I can well imagine that, given the things I see every day.
I did archaeology in college. I wasn't even thinking about that as science. I actually worked on an excavation, and as part of my classical studies, I did archaeology and some anthropology, which I guess counts as science. Just
Yes,
not physics. Just not
they're
physics.
called the soft sciences. And well, it'll be interesting. That's one place where we might go further than Thomas Kuhn, because he's mainly talking about the physical sciences, physics, chemistry, biology. Okay, so can we continue? Anybody want to read next?
I can take the
Okay, let me
iPad.
just make sure I know where we were.
Oh,
If science is the
here.
in recent years, is
Yes.
that where we are?
Yep.
Okay.
Yes.
Just tap it to move it when you're ready.
Okay, I know. I just went back. Okay. In recent years, however, a few historians of science have been finding it more and more difficult to fulfill the functions that the concept of development by accumulation assigns to them. As chroniclers of an incremental process, they discover that additional research makes it harder, not easier, to answer questions like, when was oxygen discovered? Who first conceived of energy conservation? Increasingly, a few of them suspect that these are simply the wrong sorts of questions to ask. Perhaps science does not develop by the accumulation of individual discoveries and inventions. Simultaneously, these same historians confront growing difficulties in distinguishing the scientific component of past observation and belief from what their predecessors had readily labeled error and superstition. The more carefully they study, say, Aristotelian dynamics, phlogistic chemistry, or caloric thermodynamics, the more certain they feel that those once current views of nature were, as a whole, neither less scientific nor more the product of human idiosyncrasy than those current today. If these out-of-date beliefs are to be called myths, then myths can be produced by the same sorts of methods and held for the same sorts of reasons that now lead to scientific knowledge. If, on the other hand, they are to be called science, then science has included bodies of belief quite incompatible with the ones we hold today. Given these alternatives, the historian must choose the latter. Out-of-date theories are not, in principle, unscientific because they have been discarded. That choice, however, makes it difficult to see scientific development as a process of accretion. The same historical research that displays the difficulties in isolating individual inventions and discoveries gives ground for profound doubts about the cumulative process through which these individual contributions to science were thought to have been compounded.
Can I say something here?
Yeah,
Yes.
I felt like that was a good pausing point.
So I think this view of a single person making a scientific discovery is one of our biggest fallacies, and it's a very Western notion, because in reality, there are always many people pursuing scientific questions, and many times, I mean, you have to look back in, I don't know a lot of scientific history, but what little I do know is, you know, there are, as Greg alluded to, there are many instances of, you know, the true discoverer not being the first one, and in fact, sometimes not even the same culture that first came across a scientific finding. So yeah, so this whole thing is difficult.
Right.
I mean, like,
right.
I guess we'll see this as we go, but though, I mean, when he uses the word, it's not a process of accretion, you know, and what we discard is not necessarily unscientific. I'm not sure why we would think of it that way, because obviously the process of making new discoveries and shedding old ones is a part and parcel of the broader process, right? So it doesn't seem incompatible to me with the process, or with a process of, you know, newer and newer thinking, so to speak.
Is it a matter of us looking at it back with a lens, like something like phrenology once was considered science, I guess, right? And yet more modern thinking says that was born out of racism, you know, and it actually doesn't have, you know, scientific roots, and therefore, because we can clearly label it as being flawed in some way, therefore it wasn't scientific at its time. I'm almost wondering if that's the general consensus that or whoever wrote the introduction.
I think I would say it a little differently. Phrenology started out with a methodology,
Yes.
hypotheses, theories, and what they found is that the questions that they were asking did not actually have a bearing on but it was absolutely the proper use of the scientific method. Phrenology ended itself as a science by proving itself not to be a reliable methodology to ask questions.
Interesting.
So
Right,
it's
but they
scientific
did use the scientific process.
Yeah,
That is true.
right.
And when I think of discredited scientific.
Well, I will say as an educator that I am very suspicious of a lot of education psychology research, because the essence of teaching is that kids learn from people they love, and teaching is all about having relationships. It doesn't matter if you deliver content if the kids aren't interested in the content, right? Kids decide what they learn and don't learn, but a lot of education psychology, says that if you present things in this certain way, that kids will automatically learn it, and that's bullshit. As any real teacher can tell you, but where teachers are administrated by people who believe all that stuff that they have time to research because they're not busy learning in a classroom how kids actually learn. So can we move on?
Yes.
Okay. Margaret, would you like to continue reading, or are you ready to pass it on?
Yeah, I can read a little more.
We'll start to compound it, right?
Yep. The result of all these doubts and difficulties is a historiographic revolution in the study of science, though one that is still in its early stages. Gradually, and often without entirely realizing they're doing so, historians of science have begun to ask new sorts of questions and to trace different, and often less than cumulative, developmental lines for the sciences. Rather than seeking the permanent contributions of an older science to our present vantage, they attempt to display the historical integrity of that science in its own time. They ask, for example, not about the relation of Galileo's views to those of modern science, but rather about the relationship between his views and those of his group, i.e. his teachers, contemporaries, and immediate successors in the sciences. Furthermore, they insist upon studying the opinions of that group and other similar ones from the viewpoint, usually very different from that of modern science, that gives those opinions and the maximum internal coherence and the closest possible fit to nature. Seen through the works that result, works perhaps best exemplified in the writings of Alexander Poiré, science does not seem altogether the same enterprise as the one discussed by writers in the older historiographic tradition. By implication, at least, these historical studies suggest the possibility of a new image of science. This essay aims to delineate that image by making explicit some of the new historiography's implications. Keep going.
If you'd like.
Sure. What aspects of science will emerge to prominence in the course of this effort? First, at least in order of presentation, is the insufficiency of methodological directives by themselves to dictate a unique substantive conclusion to many sorts of scientific questions. Instructed to examine electrical or chemical phenomena, the man who is ignorant of these fields, but who knows what it is to be a scientific, may legitimately reach any one of a number of incompatible conclusions. Among those legitimate possibilities, the particular conclusions he does arrive at are probably determined by his prior experience in other fields, by the accidents of his investigation, and by his own individual makeup. What beliefs about the stars, for example, does he bring to the study of chemistry or electricity? Which of the many conceivable experiments relevant to the new field does he elect to perform first? And what aspects of the complex phenomenon that then results strike him as particularly relevant to an elucidation of the nature of chemical change or of electrical affinity? For the individual at least, and sometimes for the scientific community as well, answers to questions like these are often essential determinants of scientific development. We shall note, for example, in section 2, that the early developmental stages of most sciences have been characterized by continual competition between a number of distinct views of nature, each partially derived from, and all roughly compatible with, the dictates of scientific observation and method. What differentiated these various schools was not one or another failure of method. They were all scientific, but what we shall come to call their incommensurable ways of seeing the world and of practicing science in it. Observation and experience can and must drastically restrict the range of admissible scientific belief, else there would be no science. But they cannot alone determine a particular body of such belief. An apparently arbitrary element, compounded of personal and historical accident, is always a formative ingredient of the beliefs espoused by a given scientific community at a given time.
All right, I think that's a good place to stop. Any comments about that? You're beginning to understand why I think of this as one of the most important books of the 20th century?
Maybe.
Well, certainly a lot of people I listen to or read cite this book. So, you know, and for a 50-year-old book, that's saying something.
Yeah, well, 70 years now.
Yeah, I was going to say 70 or 62, right?
Well, yeah, but his ideas were born about a decade before this book was published.
Right. Yeah.
So when you read the introduction, you'll find that he was going to be a physicist, and he became a historian of science because he was struck by some of these things that he's writing about in the intro. And it took him 10 years, mainly because he was teaching in a different field that he had been trained in to have enough time and space to write his observations.
Yeah.
So anyway, I'd like to read now, if it's okay with everybody.
Sure, absolutely.
The element of arbitrariness does not, however, indicate that any scientific group could practice its trade without some set of received beliefs, nor does it make less consequential the particular constellation to which the group at a given time is in fact committed. Effective research scarcely begins before a scientific community thinks it has acquired firm answers to questions like the following. What are the fundamental entities of which the universe is composed? How do these interact with each other and with the senses? What questions may legitimately be asked about such entities, and what techniques employed in seeking solutions? At least in the mature sciences, answers or full substitutes for answers to questions like these are firmly embedded in the educational initiation that prepares and licenses the student for professional practice. Because that education is both rigorous and rigid, these answers come to exert a deep hold on the scientific mind. That they can do so much does much to account for both the peculiar efficiency of the normal research activity and for the direction in which it proceeds at any given time. When examining normal science in sections 3, 4, and 5, we shall want finally to describe that research as a strenuous and devoted attempt to force nature into the conceptual boxes supplied by professional education. Simultaneously, we shall wonder whether research could proceed without such boxes, whatever the element of arbitrariness in their historic origins and, occasionally, in their subsequent development. Yet, that element of arbitrariness is present, and it too has an important effect on scientific development, one which will be examined in detail in sections 6, 7, and 8. Normal science, the activity in which most scientists inevitably spend almost all their time, is predicated on the assumption that the scientific community knows what the world is like. Much of the success of the enterprise derives from the community's willingness to defend that assumption, if necessary, at considerable cost. Normal science, for example, often suppresses fundamental novelties because they are necessarily subversive of its basic commitments. Nevertheless, so long as those commitments retain an element of the arbitrary, the very nature of normal research ensures that novelty shall not be suppressed for very long. Sometimes a normal problem, one that ought to be solvable by known rules and procedures, resists the reiterated onslaught of the ablest members of the group within whose competence it falls. On other occasions, a piece of equipment designed and constructed for the purpose of normal research fails to perform in the anticipated manner, revealing an anomaly that cannot, despite repeated effort, be aligned with professional expectation. In these and other ways besides, normal science repeatedly goes astray. And when it does, when, that is, the profession can no longer evade anomalies that subvert the existing tradition of scientific practice, then begin the extraordinary investigations that lead the profession at last to a new set of commitments, a new basis for the practice of science. The extraordinary episodes in which that shift of professional commitments occurs are the ones known in this essay as scientific revolutions. They are the tradition-shattering complements to the tradition-bound activity of normal science. I think I'll stop there in case there are questions or comments.
I assume in the later essays, he goes into some examples.
Yes, as a matter of fact, most of this is examples of how scientific revolutions occurred.
Okay.
And as I mentioned privately, I'm going to say this on the recording, that most of the criticism of this book is that Kuhn, he coined the word paradigm for the tradition shattering complements. The tradition bound activity of normal science is doing research under a paradigm. And so the criticism is that he used the word paradigm to mean three different things and didn't distinguish between them. So a lot of later review of this work is about separating the three different kinds, examples of paradigm that Kuhn conflated.
Okay. Yeah, I think
Can I
it'll be,
ask?
go ahead,
What?
Lisa.
I was just going to say, can I ask really quick, what is he referring to as normal science? Would that be things that we would use in our everyday life? For example, making medicine better, or like clothing technology, like fabric technology better, or housing stuff better? Is that what he's referring to as normal science, as opposed to, like, I don't know, science, like the new James Webb telescope, which would be not, to me, normal science. That's above and beyond daily science. I'm not sure he's referring to.
I want to stop you because I understand your question very well. Does anybody else have an answer to that? Because having read the whole book recently, I have an answer. I have a Kuhnian answer. Anybody else? Okay, so yes, Lisa, what you mentioned might be examples of normal science, but on the other hand, you mentioned more engineering and technology tweaking than actual science. Normal science would mainly consist of measuring things, trying to further refine the accuracy of a measurement, the precision of a measurement. It would be trying to design experiment when theories predict things will happen. It's designing experiments to show that to demonstrate the veracity of the theory, and that's where those anomalies crop up. If they're like, for example, in physics, there's been the development of a standard model of the physical world, and physicists have been trying to demonstrate that the standard model actually fits what's going on in the universe. And I believe our friend, I think everybody here except Linda knows our friend Steve Dillingham. He and I often debated. I feel like we're not going to get very much farther in physics until we have a paradigm shift. And he thought that, no, the paradigm is fine. So.
Yes, I wish Steve were here. It would be very fun to have him in this discussion. It seems to me, if we look at, I know you don't have the book, Lisa, if we look at this last paragraph about where he says, in these and other ways besides, normal science repeatedly goes astray. And then he goes on to talk about the shifts that extraordinary investigations that lead to a new set of commitments. So it seems to me what he's talking about is, when he says normal, which is a strange word, is it's under the normal set of assumptions, like you said, under the standard model, until such time as a new standard model is either determined, discovered, whatever that is, taken on board, and then your quote unquote normal resumes, right?
I guess.
That would make sense to me.
I was gonna ask it similarly, which is anyone ever doing not normal science, or is it just afterward that when the results don't come out the way you expected, that you're like, something's not normal about this science I've been doing?
Then it becomes abnormal science.
Is it abnormal? Is it unnatural science? Is it, and does I don't think anyone ever starts out trying to do that, is what it sounds like. It just, the results are what make it not normal.
Right. And so, no, the opposite of normal science is revolutionary science. And back when I first read this book, the example that I gave the most was that for 1,000 years, research in astronomy, which was the first mature science, was based on the Ptolemaic cosmology. The idea that Earth was the center of the universe, right? And under the Earth was Hades, the underworld, and there was another larger sphere that surrounded the Earth, and on the inside of that sphere, the stars were attached, and the outside was heaven, right? And the reason that planets are called wanderers is because they would seem to make these little corkscrew motions. And so a lot of astronomy was about understanding how the planets were attached to the outer ball and by what mechanism they moved the way they did. And so it took 1,000 years for someone to say, wait a minute, what if these things are actually orbiting? What if the Earth is orbiting around the sun? And so, as you'll see, he describes in the book, at first, the Keplerian cosmology didn't have as much explanatory power as the Ptolemaic. So there was a big struggle. It took a long time to switch from the paradigm of the Ptolemaic cosmology to the Copernican cosmology.
Did you say astronomy was the oldest mature science?
I'm not going to answer definitively. It's certainly one of.
One of, okay. Yeah, interesting. I don't know. I don't have any information one way or the other. It just struck me as really, I feel like there might have been some more that were, but carry on. That was just an aside.
No, it's like a science is born when there's a methodology. And even before Galileo perfected the telescope, there were ways of imaging and doing math with the position of planetary bodies. Until the discovery of cells, there was no modern biology. There was taxonomy, but and now genetic engineering or genetic understanding the genetic code has shown us that sometimes the same structure evolved independently, and sometimes the structure was inherited from another organism. So the more we understand, the more different kinds of questions we can ask. There wasn't really a science of chemistry until we understood atomic theory, right? Because until we understood what atoms of substances were, there wasn't any way to look at their movement in a modern way.
Or what made up a molecule.
Yeah, exactly. Okay, now I lost track of where I was. What's the next paragraph?
The most obvious examples.
Okay.
Looks like it's your turn, Linda.
Okay. The most obvious examples of scientific revolutions are those famous episodes in scientific development that have often been labeled revolutions before. Therefore, in sections 9 and 10, where the nature of scientific revolutions is first directly scrutinized, we shall deal repeatedly with the major turning points in scientific development associated with the names of Copernicus, Newton, Lavoisier, and Einstein. More clearly than most other episodes in the history of at least the physical sciences, these display what all scientific revolutions are about. Each of them necessitated the community's rejection of one-time honored scientific theory in favor of another incompatible with it. Each produced a consequent shift in the problems available for scientific scrutiny and in the standards by which the profession determined what should count as an admissible problem or as a legitimate problem solution. And each transformed the scientific imagination in ways that we shall ultimately need to describe as a transformation of the world within which scientific work was done. Such changes, together with the controversies that almost always accompany them, are the defining characteristics of scientific revolutions. Shall I go on?
Yes, please.
These characteristics emerge with particular clarity from a study of, say, the Newtonian or the chemical revolution. It is, however, a fundamental thesis of this essay that they can also be retrieved from the study of many other episodes that were not so obviously revolutionary. For the far smaller professional group affected by them, Maxwell's equations were as revolutionary as Einstein's, and they were resisted accordingly. The invention of other new theories regularly and appropriately evokes the same response from some of the specialists on whose area of special competence they impinge. For these men, the new theory implies a change in the rules governing the prior practice of normal science. Inevitably, therefore, it reflects upon much scientific work they have already successfully completed. That is why a new theory, however special its range of application, is seldom or never just an increment to what is already known. Its assimilation requires the reconstruction of prior theory and the reevaluation of prior fact, an intrinsically revolutionary process that is seldom completed by a single man and never overnight. No wonder historians have had difficulty in dating precisely this extended process that their vocabulary impels them to view as an isolated event. Nor are new inventions of theory the only scientific events that have revolutionary impact upon the specialist in whose domain they occur. The commitments that govern normal science specify not only what sorts of entities the universe does contain, but also, by implication, those that it does not. It follows, through the point which will require extended discussion, that though the point will require extended discussion, that a discovery like that of oxygen or X-rays does not simply add one more item to the population of the scientist's world. Ultimately, it has that effect, but not until the professional community has reevaluated traditional experimental procedures, altered its conception of entities with which it has long been familiar, and in the process, shifted the network of theory through which it deals with the world. Scientific fact and theory are not categorically separate, except perhaps within a single tradition of normal scientific practice. That is why the unexpected discovery is not simply factual in its import, and why the scientist's world is qualitatively transformed as well as quantitatively enriched by fundamental novelties of either fact or theory.
Okay. So I think this is just perfect. Any questions or comments? We're getting to the end of this passage, and I think we can finish up and take it from there.
I'm just trying to grasp what it means. Scientific fact and theory are not categorically separable.
In other words, there's a relationship between facts and the theories that underlie them, that if the theory is surpassed, then a new relationship of what used to be the facts have to be connected to the new theory.
Okay.
All right, that one affects the other. And so they're not separable because, like I said, the teacher and the learner cannot be separated as education psychology tries to do, for example.
And it also explains why so many revolutionary theories are, crushed and, made heresy, because if you're right, then everything I have done up until this point in my life comes into question and is possibly not even valid anymore. So it's amazing, that any of them ever come to light versus, the pressure of current normal science trying to say, no, you're an anomaly. You're not the new reality.
You are absolutely correct. And that's the crux of the biscuit, that new scientists, younger scientists who don't have the commitment to the old theories are the ones that actually announce what those anomalies resulted in, that the people who created the anomalies and resolved them aren't willing to say.
Exactly. Yeah, because they're at the top of their own pinnacle of, historical, like scientific progress and research, and saying, hey, none of that's actually real, or no longer valid, then you're at the bottom again, right? And so there's the accretion model. I think that does make sense, that things accrete and then they sort of get washed away by the ocean, right, and they have to accrete again.
And there's one other thing, I'm just going to insert this here. We will discover this later in the book, that a cosmology as false as the Ptolemaic cosmology allows us to do lots of useful science. If we were, instead of on a Zoom meeting, if we were out on a boat in the middle of the ocean, we could still pretend that the stars are a big sphere and make some calculations and figure out where we were on the planet, right? There's lots of things that the Ptolemaic cosmology, as false as it is, allows us to correctly predict about our existence. So scientific theories don't have to be true in order to be useful. And one of the things with contemporary science is most people think the ones we happen to have now are all true rather than simply useful. And kind of what, Barbara.
But we don't know what we don't know.
Right. But we've had lots of discussions where I've posited that the theory is actually false, although useful, and perhaps you have more commitment to the truth of the theory. Right. So anyway, I like to read, but would anybody else like to read before me?
You can go.
Okay, you just have to remind me.
This extended conception of the nature of scientific revolutions.
That's the beginning of the paragraph? Wow.
Yes.
Okay.
Yes.
This extended conception of the nature of scientific revolutions is the one delineated in the pages that follow. Admittedly, the extension strains customary usage. Nonetheless, I shall continue to speak even of discoveries as revolutionary because it is just the possibility of relating their structure to that of, say, the Copernican revolution that makes the extended conception seem to me so important. The preceding discussion indicates how the complementary notions of normal science and of scientific revolutions will be developed in the 9 sections immediately to follow. The rest of the essay attempts to dispose of 3 remaining central questions. Section 11, by discussing the textbook tradition, considers why scientific revolutions have previously been so difficult to see. Section 12 describes the revolutionary competition between the proponents of the old normal scientific tradition and the adherents of the new one. It thus considers the process that should somehow, in a theory of scientific inquiry, replace the confirmation or falsification procedures made familiar by our usual image of science. Competition between segments of the scientific community is the only historical process that ever actually results in the rejection of one previously accepted theory or the adoption of another. Finally, Section 13 will ask how development through revolutions can be compatible with the apparently unique character of scientific progress. For that question, however, this essay will provide no more than the main outlines of an answer, one which depends upon characteristics of the scientific community that require much additional exploration and study. Undoubtedly, some readers will already have wondered whether historical study can possibly affect the sort of conceptual transformation aimed at here. An entire arsenal of dichotomies is available to suggest that it cannot properly do so. History, we too often say, is a purely descriptive discipline. The theses suggested above are, however, often interpretive and sometimes normative. Again, many of my generalizations are about the sociology or social psychology of scientists, yet at least a few of my conclusions belong traditionally to logic or epistemology. In the preceding paragraph, I may even seem to have violated the very influential contemporary distinction between, quote, the context of discovery, unquote, and, quote, the context of justification, unquote. Can anything more than profound confusion be indicated by this admixture of diverse fields and concerns? Having been weaned intellectually on these distinctions and others like them, I could scarcely be more aware of their import and force. For many years, I took them to be about the nature of knowledge, and I still suppose that, appropriately recast, they have something important to tell us. Yet, my attempts to apply them even grosso modo to the actual situations in which knowledge is gained, accepted, and assimilated have made them seem extraordinarily problematic. Rather than being elementary logical or methodological distinctions, which would thus be prior to the analysis of scientific knowledge, they now seem integral parts of a traditional set of substantive answers to the very questions upon which they have been deployed. That circularity does not at all invalidate them, but it does make them parts of a theory, and by doing so, subjects them to the same scrutiny regularly applied to theories in other fields. If they are to have more than pure abstraction as their content, then that content must be discovered by observing them in application to the data they are meant to elucidate. How could history of science fail to be a source of phenomena to which theories about knowledge may legitimately be asked to apply? Comments, questions, thoughts?
Why would he be saying back then that epistemology or theories of knowledge and science were not considered compatible? I mean, understanding the history of science.
Oh, I can't really formulate a good answer to that question, but it's here in the chapter.
I know, I'm trying to, I may have just missed something, but
Anybody else?
he says that for many years I took them to be about the nature of knowledge, yet my attempts to apply them to the actual situation in which knowledge is gained have made them seem extraordinarily problematic. I don't know, I'm not getting it anyway.
Well,
Yeah.
I'll continue
He
thinking
may
about
be-
how
he-
to answer that.
He sounds like he's talking in a very, I mean, I'm simplifying it, but he's talking in a very broad way about, what has become to be very accepted as a multidisciplinary analysis, right? Which, from what I understand, was something that was, not always, not completely accepted or understood at the time. And that, where he's saying, can anything more than profound confusion be indicated by an admixture of diverse fields and concerns? And so I think what he was doing was he was gathering together observations from different fields and vantage points to try to look from above at how scientific progress was achieved, under its ways of its methodologies and its ways of accumulating knowledge.
And I think that you will begin to understand exactly what he's talking about as you see more and more examples of trying to look at these revolutions, at what people were saying at the time and what textbooks later said about what people were saying at the time.
Right.
And so, because it's that the history has to preserve coherently the thought, the pre-anomaly thought of the science, and describe the transformation to the revolution and the beginning of the new normal science under a new paradigm. So I think it'll become more and more obvious to you as we go through the examples.
Very interesting.
So I think we have enough time to just start on section 2, the route to normal science.
Okay, I'll go.
Marvelous.
In this essay, quote, normal science means research firmly based upon one or more past scientific achievements that some particular scientific community acknowledges for a time as supplying the foundation for its further practice. Today, such achievements are recounted, though seldom in their original form, by science textbooks, elementary and advanced. These textbooks expound the body of accepted theory, illustrate many or all of its successful applications, and compare these applications with exemplary observations and experiments. Before such books became popular early in the 19th century, and even more recently in the newly matured sciences, many of the famous classics of science fulfilled a similar function. Aristotle's Physica, Ptolemy's Almagest, Newton's Principia in Optics, Franklin's Electricity, Lavoisier's Chemistry, and Lyell's Geology. These and many other works served for a time implicitly to define the legitimate problems and methods of a research field for succeeding generations of practitioners. They were able to do so because they shared two essential characteristics. Their achievement was sufficiently unprecedented to attract an enduring group of adherents away from competing modes of scientific activity. Simultaneously, it was sufficiently open-ended to leave all sorts of problems for the redefined group of practitioners to resolve. Achievements that share these two characteristics I shall henceforth refer to as, quote, paradigms, a term that relates closely to normal, quote, normal science. By choosing it, I mean to suggest that some accepted examples of actual scientific practice, examples which include law, theory, application, and instrumentation together, provide models from which spring particular coherent traditions of scientific research. These are the traditions which the historian describes under such rubrics as Ptolemaic astronomy or Copernican, Aristotelian dynamics or Newtonian, corpuscular optics or wave optics, and so on. The study of paradigms, including many that are far more specialized than those named illustratively above, is what mainly prepares the student for membership in the particular scientific community with which he will later practice. Because he there joins men who learned the basis of their field from the same concrete models, his subsequent practice will seldom evoke overt disagreement over fundamentals. Men whose research is based on shared paradigms are committed to the same rules and standards for scientific practice. That commitment and the apparent consensus it produces are prerequisites for normal science, i.e., for the genesis and continuation of a particular research tradition.
Okay. Questions or comments? Let me see if I can remember. I was thinking of one. Oh yes, I was thinking of somebody whose research interests me, but is almost universally vilified in the scientific community. There's a biologist named Rupert Sheldrake who proposed that there was transfer of conscious energy between living beings. And one of my favorite experiments of his is one where he took pet owners and their pets, and he set up video to observe the behavior of the owner and the pet simultaneously. And in one experiment, he would call the human and say, I want you to intend to go home, get your coat, get your keys, and leave your office with the intention of going home. And other times he would call the guy and say, I want you to not form the intention of going home. I want you to get your coat, get your keys, but with the intention of going somewhere else, going for a drive, going to a happy hour, whatever. And he was observing the people's dogs. And at the moment where they formed the intention to go home, there was some evidence that the dog became aware that his master was coming home. But because there's no materialist way of explaining such energy, because you can't measure it, right? We don't know what it is to measure it. His insistence that such things happen got him, his papers retracted and him removed from the Royal Society of Biology and so on and so forth. And so that's one of the reasons that I was particularly interested in his work is after having read this, and we'll see later, like the way scientists dismiss, often rather cruelly, anomalies that don't yet have a physical explanation or a materialist explanation. All right. So anyhow. Shall we continue?
I think it's your turn, Margaret, if you
Yeah.
want to, achievements.
I will, yeah. Oh, no, you read
No?
this. No,
Okay.
next page. No, I was just sitting in, and maybe this is sort of a comment before we go on, is, so that is his explicit definition of a paradigm at this point, is something that is sufficiently unprecedented to attract an enduring group of adherents away from competing modes of scientific activity, and sufficiently open-ended to leave all sorts of problems for everyone to kind of go and solve themselves. Is that how he's,
Yes.
that's his definition of paradigm?
That's his first definition.
Okay, okay. All right, I just wanted to make sure that I got that. Okay, so we're starting on, I can't tell pages on an iPad, but because in this essay, the concept of a paradigm will often substitute for a variety of familiar notions, more will need to be said about the reasons for its introduction. Why is the concrete scientific achievement as the locus of professional commitment prior to the various concepts, laws, theories, and points of view that may be abstracted from it? In what sense is a shared paradigm a fundamental unit for the student of scientific development, a unit that cannot be fully reduced to logically atomic components, which might function in its stead? When we encounter them in section 5, answers to these questions and to others like them will prove basic to an understanding both of normal science and of the associated concept of paradigms. That more abstract discussion will depend, however, upon a previous exposure to examples of normal science or of paradigms in operation. In particular, both these related concepts will be clarified by noting that there can be a sort of scientific research without paradigms, or at least without any so unequivocal and so binding as the ones named above. Acquisition of a paradigm and of the more esoteric type of research it permits is a sign of maturity in the development of any given scientific field.
I think you should keep going.
Yeah. I just wanted to read that last sentence again because I kind of
Sure.
updated that I didn't understand it. Acquisition of a paradigm and of the more esoteric type of research it permits is a sign of maturity in the development of any given scientific field. If the historian traces the scientific knowledge of any selected group of related phenomena backward in time, he is likely to encounter some minor variant of a pattern here illustrated from the history of physical optics. Today's physics textbooks tell the student that light is photons, i.e., quantum mechanical entities that exhibit some characteristics of waves and some of particles. Research proceeds accordingly, or rather, according to the more elaborate and mathematical characterization from which this usual verbalization is derived. That characterization of light is, however, scarcely half a century old. Before it was developed by Planck, Einstein, and others early in this century, physics texts taught that light was transverse wave motion, a conception rooted in a paradigm that derived ultimately from the optical writings of Young and Fresnel in the early
That's Fresnel.
Fresnel, oh, thank you, in the early 19th century. Nor was the wave theory the first to be embraced by almost all practitioners of optical science. During the 18th century, the paradigm for this field was provided by Newton's optics, which taught that light was material corpuscles. Corpuscles? At that time, physicists sought evidence, as the early wave theorists had not, of the pressure exerted by light particles impinging on solid bodies. These transformations of the paradigms of physical optics are scientific revolutions, and the successive transition from one paradigm to another via revolution is the usual developmental pattern of mature science. It is not, however, the pattern characteristic of the period before Newton's work, and that is the contrast that concerns us here. No period between remote antiquity and the end of the 17th century exhibited a single, generally accepted view about the nature of light. Instead, there were a number of competing schools and sub-schools. most of them espousing one variant or another of Epicurean, Aristotelian, or Platonic theory. One group took light to be particles emanating from material bodies. For another, it was the modification of the medium that intervened between the body and the eye. Still another explained light in terms of an interaction of the medium with an emanation from the eye. And there were other combinations and modifications besides. Each of the corresponding schools derived its strength from its relation to some particular metaphysic, and each emphasized, as paradigmatic observations, the particular cluster of optical phenomena that its own theory could do most to explain. Other observations were dealt with by ad hoc elaborations, or they remained as outstanding problems for further research. Okay.
Yes. So that just gives a little idea about, there are many sciences, and that's why astronomy is one of the oldest ones, because we had a way, there was a shared view of the nature of the universe. Right? Wrong though it was, no one disputed the Ptolemaic cosmology for a long time, for centuries. Okay, shall we do one more?
Can I ask something really quick? And I know that this is going to sound off base, but it's something that keeps kind of popping into my mind. And bear with me as well. I'm not particularly a religious person, but I keep kind of coming back to the thought that perhaps, and this might not be a way to even be answered, but how has religion affected the revolution of science? Not necessarily Judeo-Christian religion, because there are older religions than that. But it's writings about, and Greg, you mentioned this too, the traditional or the original thought of like the earth being within a ball, within a sphere, the heavens and stars attached to it. That to me would seem like that would have been more of a religious construct rather than a scientific construct. And my question, I guess, is, are scientific theories truly and originally based on religious foundations? I mean, I don't know if that's an answerable question or if I'm so off base on this, but it just keeps popping into my mind.
I'll go first this time. I think, first of all, the Ptolemaic cosmology is scientific in nature because it is based on observations of movements, right? Because the stars rotated to the exact same place once a year, right?
Mm-hmm.
It's easy to conclude scientifically rather than religiously that there's a ball that the stars are attached to. If you think that the Earth is standing still, then the other ball must be in motion. So, however, it's true that throughout history, up until, say, the Renaissance and Enlightenment, all science, or the vast majority of science, was postulated on a belief in God and the way God acted in the universe. And if you look, there's a philosopher named Malebranche who he did some interesting explorations into how it was thought that how does God act in the world? There were actually scientific explorations of how God acted in the world. And one was, did God create a universe so perfectly that he was able to just set it in motion and it just went on by itself? Or did it require constant adjusting and tweaking? Right? But as science showed, many of the, what I like to call fairy stories told in the Bible, had no basis in fact,
Mhm.
science started to destroy the belief in religion.
Mhm. Okay. Like I said, it was just something that I just kept, and I'm not particularly a religious person, but I do know that traditionally science and religion have either meshed or fought against each other as well. And it just something that just kept popping in through my mind through the reading.
Yeah, well, there'll be
So,
plenty more to say about religion, but I dare say the vast majority of people participating in this reading are not believers in God.
no, I understand.
It is interesting that even, even early investigators, if you will, of of the natural world were, as Greg said, were coming from a standpoint of investigating what they knew through the lens of their religious training, the religious
Mhm.
cosmology of the societies that they lived in, you know.
Mhm.
And that was their paradigm. And then as they started making observation after observation, then they either would fit it into the paradigm.
Mhm.
Or, I mean, I'm just spouting off here. I don't have any particular knowledge on this, but
Right. No.
or they would, eventually say, well, this doesn't fit, and either they would broadcast that like Galileo, or they would keep it under wraps, or they
Mhm.
tame it for their audiences
Right.
or whatever.
Right.
But I think a perfect example is the idea that Earth is the center of the universe is kind of an easy inference to make from the fact that God created us. If God created us, then we're obviously the center of the universe,
Right.
right?
Mhm.
I feel like a lot of, I mean, especially if you're thinking about like early, who were, scientists prior to modern day, it would be the people that were educated, and where was a lot of
Right.
education held, particularly like coming out of the Middle Ages, it was in the clergy and in religious institutions.
Right.
The only people that actually read books were people with religious texts and tomes. And I'm trying to remember where I have this thought in my head that much early scientific inquiry, at least in Europe, came from this: we need to understand God. We need to understand God's creation better.
Right.
If we just keep asking, then we will find God. And I
Mhm.
feel like maybe that came from like Neil Stephenson's Baroque cycle books or something like that, because he goes through the whole Newtonian calculus and the church and all that. But I have this idea in my mind that science actually started out as a religious endeavor,
Mhm.
right? And then eventually
Right.
what is found then causes that schism, because it starts to, conflict with the fairy
And
stories,
To
as Greg
come
said.
And
apart. Right.
don't forget alchemy, the need for gold,
Yes, yeah,
Yes.
transcended even religion.
yeah, exactly. Yeah.
Very true.
I do feel like it's a particularly modern phenomena in the last 100 years, or maybe a little bit longer than that, where science and religion are considered to be polar opposites on the intellectual spectrum, as it were. I feel like that's a
Yeah.
relatively new development.
Right. Although
Yeah.
I would point out that there are many scientists who are believers in God, and they see science and religion as being preoccupied with different types of questions, and so they draw a line that allows religion and science to not conflict.
Yeah.
Mhm.
When you consider
I-
that the basis of religion is faith, which is you don't have to prove it to me. The faith
Right.
is the belief even in the absence of provable facts, right? But
Right.
Yeah, I think those scientists who are theists don't try to align their science with their religion. They just exist in parallel. And I think
Okay.
as humans, we always bring a set of assumptions and a foundation upon which we base our worldview, whether that's science or day-to-day life. And so depending on an individual's worldview and the culture at the time, science is not conducted in a vacuum. So this
Right.
foundation, makes perfect sense.
Mhm.
In some sciences, certainly in my science, which is epidemiology, we are trained in recognizing what biases that foundation brings.
Uh-huh.
I don't know that that's true in every science, though.
Mhm. Okay.
This has been really fun.
Yes, it's just perfect that we've reached a good stopping point. And by the way, will we be starting with the paragraph that's at various times?
Yep. That's
Okay.
Yep.
Okay, and that's on page 13 of my edition. Anybody have a different page number?
I think I'm on 27, but I'm on an e-version, so I don't know if the pages line up at all.
My ebook doesn't have pages. I made a bookmark.
Okay.
That's a whole reason to hate
Yeah,
ebooks.
it is. I need page numbers.
Okay.
All right,
you
I
put
just
your-
want to remind you, if anybody wants to grab that article from the chat.
Maybe you
'Cause I'm
could put
great.
it on the
Yeah.
Facebook page.
Oh, yeah, if you could put it on the Facebook page.
I will put it on the Facebook page.
Thank you, Greg. You've
Thank
been
you.
a great moderator.
And this is awesome. This is so awesome.
Mhm.
This is
Yeah,
fun.
thanks for putting this together.
Yeah.
Well, I'm having fun, and I would it's at the end is the wrong time to tell everybody. You might want to watch this at higher speed. I'll get around to learning how to put this on the Facebook page and get it there sometime in the next day or two.
Fantastic.
Okay, thank you so much.
Thank you. Nice to meet you,
Good to
Linda.
meet you, Linda.
Nice meeting you all.
Thanks for joining, Lisa.
Nice seeing
You're
you
very
again.
welcome. Thanks for the invitation.
All right.
All right.
See you next
All right.
time. Bye.
Yes, it'll be after
Bye.
the holidays.
Happy holidays
Happy
to all.
holidays.
Yes, happy holidays.
Bye.
Thank you, everyone.
All right. Bye,
Bye.
everybody.